And we're on to another one now, looking at biomass. The importance here is that we've got to remember that rather than relying on petroleum as our sole fuel of energy, petroleum's going to run out. If we keep using it at the current rate, they estimate it'll be running out in about 10 to 40 years' time. So we need to think of other ways, more renewable ways, to get energy that not only extends the use of petroleum oil, fossil fuels, but it also means that we're doing a lot of other benefits to the society. For example, if we don't use fossil fuels and we're using more renewable sources, we're releasing less carbon dioxide gases into the air, less greenhouse gas, therefore the positive effects it has with global warming, etc. And it's important that we realise this. So let's just look a bit more at biomass. So the first thing is that we want to make sure we understand is that petroleum will only last 10 to 40 years at current consumption rates. Okay, we know that biomass is very, very important, and we have previously said that biomass is material made by living organisms. Okay, so let's do another colour here. Let's go green. Right, so it's organic material. Now, what sort of examples can you think of? Well, the thing is that biomass can be wood. We've relied on wood to get energy and power and heat for thousands, tens of thousands of years. So we can use wood to heat up water, to make energy because we use it for steam, for turbines, etc. But we can also have other forms of biomass, and that might be such as organic material, right? Organic waste, such as organic food waste, garbage that we can use in things called biogas generators. So what else can we have? Well, we can ferment. We can use sugars and ferment to make ethanol. Okay, and then we can use ethanol as a source. We can burn it. We can be used as a heat source. We can also we'll just write that fermentation in. And so there's some things about biomass. Now the thing is with biomass is we must remember it is renewable as opposed to petroleum oil, which is a non-renewable source. We then have to think about, well, what's the essential feature of biomass or cellulose? Well, the thing about cellulose, and I might have to extend it up here, is that cellulose contains the essential carbon-carbon bonds that we can use to make fuel, that we can use to make plastics, right? So the carbon-carbon bonds to make organic chemicals, and we're going to be looking at that in just a second about how that happens. We also know that with cellulose is in large supply. And it's made by photosynthesis. So if we know that we have a large supply of plant material, it is renewable, it contains the carbon bonds that we need to make other organic materials, then how do we actually get this material to make things such as plastic, such as PVC, such as polyethylene, the materials that we currently get from petroleum-based? Well, I'm glad you asked, because we're going to rub this out and we're going to draw a flow chart and we're going to examine that right now. Okay, we are back. Cellulose. We know that it's a major biomass fuel source, but how do we actually use that? Well, the thing is that we've got to break cellulose down into monomers, and that requires quite a bit of energy. We can do it by acid hydrolysis. We can do enzymatic breakdown with bacteria, or enzymatic digestion. Okay, and so we crush the cellulose. Right, so we crush the cellulose, add acid to it, that hydrolyzes the bonds. Now remember, hydration is adding water to the bonds, condensation is removing the bonds, removing water to make them join together. So when we say acid hydrolysis, we're actually adding water to the cellulose to break the monomers up, and we're crushing it to increase the surface area. And of course we can use enzymatic digestion with bacteria as well. Now what does that do? Well, it breaks the cellulose up And we could say, you know, makes it to molasses or complex poly sugars. But let's just go all the way into, say, glucose. Okay, so we're making a glucose monomer here. Once we have the glucose, which is sugar, right, and of course we have sucrose, etc., which is different to glucose. We're going to learn more about that later, but if we just think about that as sugar, we can convert the glucose into a form that we can then ferment. So we can do fermentation, and it's very important that we write the conditions of fermentation here. And so the conditions will be 37 degrees Celsius. We'll have yeast. Okay, you don't not expected to remember the names of the yeast, but there's lots of different yeast you can use. A popular one is called Saccharomyces cerevisiae. That's how I pronounce it anyway. So 37 degrees yeast, but it also wants to be at anaerobic. Now, anaerobic means with minimal oxygen. We want to make sure there's no oxygen there, because if there is oxygen, then that yeast is going to respire instead of making alcohol or ethanol. Okay, it'll use that oxygen to break down the glucose in respiration and make CO2 and water. We don't want that to happen. We want it to convert the glucose into ethanol. Okay, and it's got the enzymes to do that. Okay, and so we've got the yeast, 37 degrees, anaerobic condition. So that's called fermentation. The product of fermentation from glucose is going to be ethanol. Now, of course, that's not going to be pure ethanol, so what we need to do is then distill it and make it more and more concentrated. It's getting late. I'm mispronouncing my words, but anyway, distillation. So bear with. All right, so we've got ethanol distillation there. That's going to make 95% ethanol. And then what we can do is we will then dehydrate that. Okay, so we're using, remember, conch acid, conch H+, to remove the water, and that's going to make ethylene. Once we've got ethylene, of course, then we can do polymerization reactions, and we can make polyethylene, which, remember, there was two sorts: low density polyethylene, high density polyethylene. From ethylene, we could also make polystyrene, and of course we could make polyvinyl chloride. So what we're doing here is we're going from a renewable source of energy, producing a chemical that we now majority 95% or so get from petroleum. So we're replacing how we get this feedstock to make these polymers, these commercially significant molecules. And so if we can do that, that's going to significantly lengthen our fossil fuels. It's going to decrease our use of fossil fuels and have positive impacts such as less CO2 emissions, less greenhouse gas, and positive effects on global warming, etc. So that's the flow chart on how we do that. We've got to talk about the advantages of this and the disadvantages. I'll rub this off, we'll do that a little bit, and we're done for this video.